Okay, we're gonna continue with the review. We are at exercise 24, distinguish between discrete and continuous. The number of bottles of juice sold in a cafeteria during lunch. If the number is countable, like 1, 2, 3, 4, 5, etc., it is discrete. If it's not countable and you need a tool to measure it, then it is continuous. So number of bottles, we can count them, so it is discrete. Height of the bookcases in a school library, then this is continuous, because the height could be decimals. If it can be decimal, that it can be discrete, so it is continuous. Number 26, a firm emails 2,000 people and 18% typically open email. What's the expected number of opens? The expected number of opens is the sample size times the probability of success, which is 18%. So in this case, it's going to be 0.18 times 2,000, so there will be 360. So it is NP. The expected value is N times P. 27, we're doing binomial probability in here. 65% of men consider themselves knowledgeable soccer fans. So the probability of success here is 65%. If 10 men are randomly selected, what's the probability that exactly 6 of them will consider themselves knowledgeable fans? So you select 10 people, you interview them. What's the likelihood that 6 of them, they will say that we are knowledgeable fans? So let me show you how to do that in StatCrunch. This is a binomial probability. So you go to Stat, Calculators, Binomial. Okay. We have 10, and what's the probability of success? It was 0.65. And we want to know what's the probability that 6 of them exactly means equal. And you put 6 right here. All right. And compute, and here's the answer. Let me double check, see if it was 60. Yeah, that's the answer. The answer is 0.2377. If he says what's the probability that exactly, for example, 4 of them consider themselves knowledgeable fans, you just change 6 to 4. And here's the answer right here. So you need to put the sample size, how many, and you need to put the probability of success, and then answer the questions right here. And not only here, you can do the equal here. If he says less than or equal, you can do it. Greater than or equal, you can do it. Less, greater, all of that. And there is an between as well right here. For example, if he says what's the probability between 3 and 6 people inclusive consider themselves knowledgeable fan, you can just do it from here. Okay. Next question. 28. According to Federal Communication Commission, 75% of all U.S. households have 7 TVs. So that's P is 75%. In a random sample of 15 households, what's the probability that at most 11 have cable TVs? At most 11, guys, means 11 or 10 or 9 or 8, so less than or equal to 11. So we got P is 75% and N is 15. Let me show you how to do that using StatCrunch. So we're going to change N to 15. We're going to change this to 0.75. And he says at most. At most, guys, means less than or equal to. So I'll just change this one to less than or equal to and put the 11 here because he says at most 11 and hit compute. And look, it shaded 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, all the way down. And the answer is 0.5387. Next question, the probability that a football game will go into overtime is 12%. If 200 randomly selected football games, what's the mean and the standard deviation of the number that went into overtime? So he wants the mean and the standard deviation of the binomial distribution. The mean is N times P. N is 200 and probability of success is 12%. So it will be 0.12 times 200 will be 24. The standard deviation will be the square root of N PQ. Q is the probability of failure. So this is what you do for the standard deviation. You take 0.12 and multiply it by 1 minus 0.12, which is 0.88, and then you multiply it by 200 and you find the square root of this. So it will be square root of 0.12 times 0.88 times 200, and the answer will be 4.6. So again, guys, you do square root of 0.12 times 0.88 times 200. And where did I get 0.88 from? It's 1 minus 12%, which is a probability of failure. Number 30. Now we're going to the important chapter, which is normal distribution. It's very, very important. I'd like you to pay good attention to this one. What is the area under the standard normal curve to the left of z equal 1.17? So, normal probability, go to stat, calculators, normal, right here. And we're going to be answering the question using this one. So, when he says z, the mean is 0 and the standard deviation is 1. To the left of 1.17 means less than. So, it just put 1.17 right here. Hit compute, and here's the area. Look, this is to the left of 1.17. The answer will be 0.8790. Okay, that's the answer to this question. 31. A physical fitness association is included in the mile run in its secondary school fitness test. The time for this event for boys in secondary school is known to possess a normal distribution with a mean of 450 and a standard deviation of 40. What's the probability of randomly selected boy in secondary school can run the miles in less than 358 seconds? Okay, using the normal distribution calculator. So we change the mean to what? 450, the standard deviation to 40. We're not doing with z anymore, so it's x. We need to have a mean and standard deviation. And he wants what's the probability that x less than 358, so the 358. And the answer is 0.07. So the answer will be 0.0107. 32. The length of time takes college students to find a parking spot and live parking follow a normal distribution with a mean of 4.5 and a standard deviation of 1. What's the probability that college students will spend between 3 and 5.5 minutes in order to find a parking spot? Again, we're going to use a normal calculator for this one. So let me get it. Okay, so we have what? What's the mean in this case? Okay, 4.5. The standard deviation is 1. And we need the in between here because it says between 3 and 5.5 minutes. And you're going to see this area is going to be shaded for you guys. Look, this is shaded between 3 and... It's 0.7745. That would be the answer. The answer is 0.7745 or 77.45%. Next question. The Board of Examiners that administer the real estate broker examination in a certain state found the mean to be 558 and the standard deviation 72. If the board wants to set passing score so that only the best 10% of all applicants pass, what is the passing score? Assume that the scores are normally distributed. So guys, in this question, he gives you the probability and he wants you to go backward and find the x value. And top 10% will be an area to the right. So let me show you how to demonstrate this one. So we're going to go to the normal calculator. We're going to put the mean, which is what? 558. We're going to put the standard deviation, which he says is 72. And since this is an area to the right, we're going to go to standard. We have to use the greater sign. Area to the right greater, area to the left less than. And look where I'm going to put the 10% right here, because he gives me the probability. And once I start typing, notice this field is going to become empty because that's the x value where we want the x value. Okay, see, it's empty. Once I hit compute now, okay. So anyone who scores 650 or higher will be from the top 10%, and he will be included in this. Okay. So that's the answer, 650 or more. That would be the answer to this one. So again, 650 or higher would be considered a passing score. Okay, 34. The average score for all golfers for a particular course has a mean of 68.5 and a standard deviation of 3.5. Suppose 36 golfer played the course today. So n is 36, is given us a sample, not one individual. So it's a central limit theorem now. Find the probability that the average score of the 36 golfers exceeds 69. So he wants a probability not of x, of the sample, which is x bar greater than 69. In order to do this question, guys, when we use the central limit theorem and we work with samples, the standard deviation changes. So it's no longer 3.5 when we work with samples. It is the original standard deviation divided by the square root of the sample size. So the new standard deviation is going to be 3.5 divided by square root of 36, which is 3.5 divided by 6. And if I do 3.5 divided by 6, guys, what do I get here? It's 0.58. So this is the standard deviation that we must use when using static crunch. Not the 3.5, it would be wrong. When we have a sample size, you must use the standard deviation of the sample means, which is the original standard deviation divided by the square root of the sample size. Let me show you how to use static crunch right here. Okay, so we're going to put the mean. The mean doesn't change, whether it is the original population or the sample means, which is 68.5. Okay, and then standard deviation, not 3.5, as I said, it's going to be 0.58. And we need greater than what? 69. That was the question. And that x should be actually x bar, but I cannot change that one. It's a sample mean. So you just hit compute, and that's the answer, 0.1943. So it will be 0.1943 for this question. Now we're talking about confidence intervals. A survey of 500 non-fatal accidents showed that 142 involved uninsured driver. Construct a 99% confidence interval for the proportion of fatal accident that involved an insured driver. Interpret the confidence interval in words. So let me show you how to do this in StatCrunch. Okay, we're done with the calculator here. So we go to stat. It's a proportion stats. We're doing proportion. One sample with summary. Okay. Number of successes is 142. Number of observation is the sample size, which is 500. And look, I have to select confidence interval, and he wants 99% confidence interval. Compute, and here we go. This is the interval right here. The lower limit is the lowest value in the interval. The upper limit is the highest value in the interval. If you are to, that could be a multiple choice question. If you are to select an answer, so this is how the answer will be spelled out. With 99% confidence, we can say that the true proportion of fatal accident that involved uninsured drivers is between 23.2% and 33.6%. So I changed, those decimals to percentages. So again, with 99% confidence, we can see that the true proportion of fatal accidents involved uninsured drivers is between 23.2% and upper limit here 33.6% or 59%. Okay. A local bank needs information concerning the savings account balances of its customers. A random sample of 14. So N is 14. Accounts was checked. The mean balance was 785.75. So that's X bar. Sample mean. With a standard deviation, that's S 250.50. Find a 95% confidence interval for the true mean. Assume that the account balances are normally distributed. Round to the nearest cent. So he wants a 95% confidence interval. So this is T stats. We're going to go to T. And let me show you how to do this. So we're going to go to the interval. Close this one. We're going to go to stat. When you work with the mean, it's t-stats, one sample with summary. And let's show you guys right here. Okay, sample mean, which is 785.75. Sample standard deviation, 250.50. Sample size is 14. And what the confidence level we want 95%. It's 95%. Just hit compute. And here you go. That is, so it's 641. He wants to the nearest cent, so it will be 641.12 and 930.38. And let's go back to the question and interpret the question properly. So, okay, so with 95% confidence, we can say that the true mean balance of accounts is between $641.12 and $930.38 dollars. Okay. Next question. 15 randomly selected men were asked to run on a treadmill for 6 minutes. After 6 minutes, their pulses were measured and the following data were obtained. Construct a 95% confidence interval for the population mean. So we got those data. We're going to put them in StatCrunch and show you how to find the mean when the data set is given. Okay, so you go to stat. T-stats, when he gives you the data set, one sample but not with summary, with data. I put my data in variable 3. Okay, and the confidence level is 95. Let's make sure that we have the confidence level right here. So we're going to select it. And that's it. Compute. So 93.66 and 107.13. Let's go back to the answer sheet and look them up. It looks like the first choice is the one, 93.7, 107. We are 95% confident that the mean pulse rate of men after 6 minutes of exercise is between 93.7 and 107.1 beats per minute. Okay, that would be likely also a multiple choice question. The mean age of lawyers in New York is 48.5. Write the null in the alternative hypothesis. So it will be the null hypothesis mean equals 48.5, and the alternative will be the complement of equal, which is not equal. And here, guys, note that the claim is in the null hypothesis because it says is, which is the equal sign. Next question, 39. The mean age of principals at the local district is 45.5. If hypothesis test is performed, how should you interpret a decision that rejects the null hypothesis? First of all, let's write, just a null and the alternative hypothesis. Okay, so if you perform a hypothesis test and you reject the null hypothesis, what do we conclude? Remember, he says the mean is 45.5. That means the claim is in HO. If you perform a test and you reject the null hypothesis and the claim happened to be in the null hypothesis, which is usually not the case, then you say there is sufficient evidence to reject the claim because you rejected HO, which is actually the claim itself. So then you say there is sufficient evidence to reject the claim. So the answer will be B in this case. Next one. The mean age of judges in Dallas is more than 53.8. So now the claim is in H1, and this is usually the case. How should you interpret a decision that fails to reject the null hypothesis? If you cannot reject the null hypothesis, guys, and the claim is in H1, you cannot support the claim. So you say there is not enough evidence to support the claim. So in this case, would be C. An airline claims that more than 20% of its passengers, once you see the percent, you know it's a proportion, purchase their tickets using their frequent flyer miles. In a sample of 580, so that's N, randomly selected reservation, 122 of those reservations were paid using airline frequent flyer miles. 122 is X, the number of successes. Can you support the claim at 5% level of significance? So I wrote down, the null and the alternative. HO will be P equals 20%. H1 will be P is greater than 20%, which is the claim. And we're going to run a proportion stats test. Let me show you how we're going to do that. So we're going to go to stat, proportion stats, one sample, proportion stat, one sample with summary. And we're going to enter the information. Number of successes is the smaller number, 122. Number of observation, which is the sample size, 580. And we're testing against 20%. You need to change it to a decimal, so there will be 0.20. And make sure to change the alternative sign, which is a greater than. And you can go here and hit compute. And look, guys, you got the Z stats, which is 0.62. The p-value, which is 0.2667, which is bigger than alpha. So we fail to reject the null hypothesis. And if you fail to reject the null hypothesis, your conclusion should be the following. There is not, anytime you fail to reject HO, you start with there is not enough evidence at the 5% level of significance to support the claim that the proportion of travelers or passengers who use their frequent flyer miles to purchase tickets is more than 20%. 42, a shipping firm suspects that the mean life of a certain brand of tire used by its truck is less than 39,000 miles. So less than 39,000 miles. To check the claim, the firm randomly selects and tests 18 of these tires. So N is 18. And gets mean lifetime of 38,350. So X bar is 38,350. With a standard deviation of 1200. So S is 1200 miles. At alpha equal 5%, test the shipping firm's claim. So let me show you the null and the alternative. So the null will be mean equals 39,000. The alternative will be mean less than 39,000 miles, which is the claim. We're going to run a t-stats. So we go to stat, t-stats. When do you use z-stats? Only when the population standard deviation is given to you. T-stats, one sample with summary. Okay, the sample mean is what? Given as 38,350. Sample standard deviation is 1200 miles. Sample size is 18. And we're testing against the value 39,000. And we need to change the mean. Less than 39,000, compute. And I got the test statistic, which is negative 2.298. And the p-value is 0.0173. Alpha is 5%, so this is less than 5%. So you can reject the null hypothesis, reject HO. And if you reject HO, guys, you can support the claim. There is enough evidence at the 5% level of significance to support the claim that, let's read the claim together, that the mean life of a certain brand of tire used by the trucks of the firm is less than 39,000 miles. Okay, we're going to do a third video for the remaining questions.